What if I stopped telling an AI how to play Flappy Bird and instead just let evolution figure it out? I created a population of completely terrible birds, gave each one a tiny neural network for a brain, and then made them compete. The birds that survived longer got to reproduce, the birds that sucked, they died. And after generations of mutation and natural selection, the birds started getting really good at Flappy Bird. So today, we are building the whole thing from scratch. No hard coded strategy, no human demonstrations, just evolution. First, we need somewhere for our little digital Darwin experiment to happen, and for that, I'm using Pygames. The program starts by creating the game window, loading the background, pipes, and bird animations, and then creating our first population. I've also separated the important settings into config.py file. Things like window size, physics constant, population size, and neural network configuration all live here. Basically, this is the control panel of the experiment. Then, we need the thing our birds are desperately trying not to hit, the pipes. Each pipe gets a randomized gap so the birds cannot simply memorize one fixed path. The pipe continuously moves towards the bird, and whenever a bird successfully passes one, it gets rewarded with more fitness. Now let's create the contestants. Instead of one bird, we are creating an entire population. Each bird has its own position, velocity, score, fitness, and most importantly, its own brain. At this point, none of them know what they are doing, and honestly, that's exactly what we want. The next problem is pretty important. How does a bird know when it should flap? We could give the AI the entire screen and make it figure out everything out itself, but that would be a massive overkill, and we don't have the kind of computing that's needed for this. Instead, I'm giving each bird just three pieces of information. First, where am I vertically? Second, how far away is the next pipe? And third, where is the center of the gap? Think of this as the bird's three senses. It doesn't understand pixels, it does not understand the concept of pipe, it simply gets numbers describing its situation. And those three numbers get normalized so the neural network has an easier time working with them. The find next pipe function makes sure we are looking at the next obstacles the bird needs to worry about. Because if you are trying to survive, you probably don't need to care about the pipe you already passed. Then update bird physics function handles the actual movement. Gravity pulls the bird down, a jump gives it an upward velocity, and surviving contributes to its fitness. Eventually, reality catches up. If a bird hits the floor or a pipe, it's dead. And once it is dead, it stops participating in the current generation. Now we get to the interesting part. Every bird needs a brain. So I give each one a small feed-forward neural network. And don't worry, we are not building some giant AI model here. The brain basically works like this. Three numbers go in, the network does some math, one number comes out. The final number answers one very simple question. Should I jump? If the output is greater than 0.5, flap. Otherwise, do nothing. Inside the network, the connection have weights. You can think of these weights as tiny knobs controlling how strong each input influences the decision. And the sigmoid function squeezes the network's output into predictable range between 0 and 1. So instead of brain saying, I have calculated 17.38, it basically says, I am 83% confident we should flap. But here's the important part. We are creating this brain with random weights, which means our first generation is going to be, well, absolutely awful. And that's where evolution comes in. At the end of a generation, we rank the birds by fitness. And this is where our experiment gets interesting. We are not manually improving the AI, we are not changing the network architecture every generation. We are simply asking which bird did better. The better a bird performs, the higher its chance of becoming a parent. Imagine every bird gets some lottery tickets. A terrible bird gets one ticket, a decent bird get 10 tickets, and the bird that absolutely dominated the game might get 100 tickets. Then we create the next generation using three evolutionary ideas: selection, crossover, mutation. First, we use elitism. The best performing bird are carried directly into the next generation. So we finally discover a bird that can survive really well. We don't want to accidentally throw its brain away. Next comes crossover. We take two parent brains and mix their weights and biases together. And then comes my favorite part, mutation. Every connection has a chance of being slightly changed. Sometimes it's a tiny adjustment, sometimes there is a much bigger random mutation. Now we can finally run the experiment. Generation 1 starts with random brains, as expected, absolute disasters. They are flying into pipes and flying into the floor. Some of them barely know what gravity is, but then we breed them. Generation after generation, the population starts changing. The really bad strategies disappear, the useful ones survive, and eventually we start seeing something that looks suspiciously like skills. The bird isn't following a script. Nobody has programmed when the pipe is here, press jump. Instead, the neural network discovered a relationship between its position, the upcoming pipe, and the gap. And the HUD let us watch the experiment in real time. We can see the current generation, how many birds still alive, the current score, and the best score. And because we are rendering every living bird, you can literally watch evolution happening. At the beginning, the screen is chaos. Later, the chaos starts disappearing. Once a generation produces a particularly strong bird, the best model can also be saved to bestmodel.json file. So the results isn't just something we can watch once, we can actually preserve the evolved brains. And this is the part I love about the project. The AI wasn't given the answer, it was given a game, a few numbers, a reward, and the ability to change. And somehow, after enough generation, it figured out how to survive. So the whole pipeline looks like this. Pygame creates the environment, the birds observe three input, their neural network decides whether to jump or not, fitness measures how well they perform, then selection, crossover, and mutation creates the next generation. And then we repeat the process again and again and again until natural selection turns a population of clueless birds into something that can actually play Flappy Bird. And if you enjoyed watching a bunch of terrible birds slowly become competent, subscribe because there's definitely more AI experiments coming soon. Happy coding, keep coding.